Hey guys, welcome again to Funly Maths. Here's another problem. Square root of 3 plus square root of m plus 9 is equal to cube root of m. Find m. So here's the solution. First, let's bring down the given equation. Square root of 3 plus square root of m plus 9 equals cube root of m. Now next is, we can let m plus 9 be equal to p. Therefore, m is equal to p minus 9. So now to write this is now square root of 3 plus square root of, in the place of m plus 9, that is p. So this is now square root of p equals cube root of m, that is p minus 9. Next is, we are going to remove this cube root by inserting a power of 3 both sides. So power of 3 and power of 3. So now, the power of 3 and the cube root is cancelled. So we're left with square root of 3 plus square root of p whole to the power of 3 equals p minus 9. Now next is this square root of 3 plus square root of p whole to the power of 3. We can split this into square root of 3 plus square root of p whole to the power of 2 times another one, square root of 3 plus square root of p, then equals p minus 9. Now, next thing to do is we can cancel the squared and the radicand. So now we're left with 3 plus square root of p times square root of 3 plus square root of p equals p minus 9. Now, next, 3 plus square root of p times square root of 3 plus square root of p equals p minus 9. So what we can do is, we can divide both sides by this, 3 plus square root of p. So now we can cancel this. We're left with square root of 3 plus square root of p equals p minus 9 over 3 plus square root of p. Now next is, we can let square root of p be equal to x, or that is p is equal to x squared. Now to continue, we can write this as square root of 3 plus x equals, for p, we have x squared minus, for 9, we can write it as 3 squared, so that they have the same power, which is 2, over 3 plus square root of t, that is x. Now, for the numerator, we have x squared minus 3 squared. By following the identity, a squared minus b squared, which is also written as a minus b times a plus b. So now we can write it as square root of 3 plus x equals x minus 3 times x plus 3 all over 3 plus x. Now for this, we can cancel x plus 3 over 3 plus x, because 3 plus x is the same with x plus 3. So this is cancelled. So we're left with square root of 3 plus x equals x minus 3. Next is, we need to remove the radical by squaring both sides. So this is cancelled. We're left with 3 plus x equals this x minus 3 to the power of 2. We have another identity, that is a minus b whole to the power of 2, which is also equal to a squared plus b squared minus 2ab. So for this, we can expand by following the identity. This is x squared plus 3 squared, that is 9, minus 2 times x times 3, that is 6x. Now, we need to take 3 plus x through the other side. So this side will be equal to 0. So now this is 0. Let's transfer the equal sign here. So x squared plus 9 minus 6x minus 3 minus x. And this is 0 equals x squared 9 minus 3, that is positive 6, negative 6x, and negative x, this is negative or minus 7x. Now for this, using the commutative property, we can write this as x squared minus 7x plus 6 equals 0. So this is a quadratic equation. Now, to apply the grouping and factoring, we are going to split this negative 7x into minus 6x minus x. So this is now x squared minus 6x minus x plus 6 equals 0. So grouping, this is the first group, and this is the second group. And then factoring, first group, the common is x. So x times x squared divided by x, that is x. Negative 6x divided by x, that is negative or minus 6. Then here the common is negative 1. Negative 1 times negative x divided by negative 1, that is positive x. Positive 6 divided by negative 1, that is negative 6, equals 0. Now the common is x minus 6. X take out x minus 6 times the remaining x minus 1 equals 0. Now we can have two equations for this. X minus 6 is equal to 0, and that is x is equal to positive 6. Other one is x minus 1 is equal to 0, and that is x is equal to positive 1. So we have the values for x is equal to 6, and x is equal to 1. Now, since our problem, we need to find the value of m, that means this is not our final answer. But let's recall, earlier, we let square root of p be equal to x, and we can use it now. So square root of p is equal to x. So using the first value of x, this is square root of p equals 6. Now let's remove the radical by squaring both sides. So this is now cancelled. We're left with p is equal to 6 squared, that is 36. So p is equal to 36. Another one is square root of p is equal to x, 1. So square root of p equals 1. Square both sides. So this is now cancelled. We're left with p is equal to 1 squared, that is 1. So our values of p is equal to 36 and p is equal to 1. Now to get the values of m, let's recall that earlier we let also m plus 9 be equal to p, and m is equal to t minus 9. So we can use this to get the value of m. So m equals p minus 9. So this is now m is equal to p, that is 36, minus 9. And this is m is equal to 36 minus 9, that is 27. So this is our first value of m. M is equal to 27. Another, m is equal to p minus 9. M is equal to 1 minus 9. And that is m is equal to negative 8. Now, since the value of m is negative 8, we cannot consider this as our true value of m. The only value of m that we consider is 27. But before we end, let's check if this value of m, which is equal to 27, is correct. So using the given equation, to check, square root of 3 plus square root of m plus 9 equals cube root of m. So now substitute, m is equal to 27. Square root of 3 plus square root of 27 plus 9 equals cube root of 27. And then square root of 3 plus square root of 27 plus 9, that is square root of 36, equals cube root of 27, that is 3. And then square root of 3 plus square root of 36, that is 6, equals 3. Now, this is square root of 3 plus 6, that is 9, equals 3. And the square root of 9 is 3, equals 3. So 3 equals 3, they are equal. That means m is equal to 27 is correct. Therefore, the value of m that will satisfy to this equation is 27. And that's all for today. For more exciting videos, don't forget to like and subscribe to Fun with Maths.